I have, folks, listen, I have handed you, guys, can I get everybody? So I've handed you a worksheet with 10 optimization problems on it. This is the key for that worksheet. I'm going to send this around in a little bit and let you take pictures of it, okay? And those of you watching at home, at the end of this video, I will add on a 5 seconds of the front and 5 seconds of the back so that you can see the key as well. We'll be right back after these messages. You're waiting for it, right? Yeah. Okay, sorry. Okay. I'm going to leave this up on the board while we work on question number 1 and I'm going to do it in blue marker so that we can erase it but still work on more. All right, so question number 1, I'm actually going to let you do a lot of the work yourself, but question number 1 is a reasonably easy question. It says that f of x is equal to x squared minus 2x minus 8 on the closed interval from -4 and up to 5, okay? And we want to identify the absolute maximum and the absolute minimum of this function on this closed interval. So here's what I want you to do. I want you all take about 30 seconds or a minute and do step 1, go. If you're watching on the video, you can do this too. Of course, you can have more time because you can press the pause button. Is anybody drowning on this step right now, or are we okay?
I thought I was drowning, but I actually realized that it's only 3 feet.
Yeah. Oh, yeah. You're right about that. Some could say that it's the kiddie pool. Yeah. Okay, so what notation are we going to write here? F prime. So we're going to say that f prime of x equals, what is the derivative? 2x minus 2. And we're going to write one more thing, equals 0. There's step 1. Now let me explain why I want you to get in the habit of writing equals 0 after the derivative when doing an optimization problem. Those of you who are considering, or those of you that do wind up taking the AP exam, I want you to know that there are some free response questions where, let's say for an optimization problem, they will give you, let's say, finding the absolute maximum and minimum is one part of the overall question. Let's say they're going to give you 3 points for that part of the question. By identifying the derivative and setting it equal to 0, they will probably, or they very well may, give you 1 whole point out of the points that they're going to give you. And here's why. You may be communicating, even if you don't finish that part of the problem, you're communicating to them, basically, well, I don't really know how to solve this problem, but I know one thing. I know that it has something to do with finding the zeros of the derivative. You're communicating to them that you know that you need the critical values to be able to do it, and that's such an important step, they may give you 1 whole point just for identifying the derivative and setting it equal to 0. Understand? Now, if you identify the derivative and don't set it equal to 0, they'll look at that and say, oh, how nice. They knew they needed the derivative, I guess. But I mean, how many other questions do you need the derivative? So maybe you're just guessing. But by writing equals 0, they now know that you need the critical values. Okay? How are we doing? Are we good? All right. Step 2. Why don't you guys take a few seconds, 30 seconds maybe, and do step 2. Identify the critical values, meaning solve for x here. Solve step 1. Find the zeros for this derivative. How many zeros are there? 1 0. And what is the 0? It's 1. It's x equals 1, right? Okay? Now I want to make a point here. Okay? Did you notice that I didn't do the algebra? Anybody notice that? Well, I mean, I could have done plus 2, right? Then crossed out and had 2x equals 2, then divided by 2 on both sides and x equals 1, right? Okay? When you were in 6th grade, that was called showing your work, right? Okay? On the AP Calculus exam, they usually do not ask you to show your work. What they want you to show is your reasoning. Do you understand? In this particular case, they understand that this is a really easy solution here, and that the 0 is x equals 1. And some people can just know this by looking at this very simple linear problem. Do you understand? They're not looking for algebra. They're looking for calculus reasoning. Okay, by writing 2x minus 2 equals 0, you are showing your reasoning that I know I need the critical values. Do you see that? But I didn't show the algebra, and that's okay. This is correct. All right, are we good so far? All right, so we got the critical values. Now we're going to go on to step 3. Let me show you how I do step 3. I will write x equals, and then I will draw a line. I'm creating a table here. Okay, oops, did I hit a button there? Put my hand in my pocket sometimes, and I don't want to accidentally turn off the recorder. All right, so I've got the my x's are going to go on the top. You know what I'm going to put on the bottom? What's that? My y values, right? But I'm not going to call it y equals. You know what I'm going to call it? I'm going to call it f of x equals, because they didn't name this function y. They're naming this function f of x. It's probably not that big of a deal, but I want to be as specific as possible. So I'm going to write f of x equals, okay? And now what I'm doing is I'm creating a table here. And the top of the table, all my x values, that's step 3. You see that? Mm-hmm. And the bottom of the table, you know what step that is?
Step 4.
That's step 4. So I'm going to put a 4 there. So here I've got step 1, step 2, step 3, step 4. How many candidates do I have in this question? 3 candidates, right? 1 critical value and 2 endpoints, okay? So I only need 3 columns here, right? And what I'll do is I'll put the endpoints here and here at the beginning and the end, and then in the middle I'll put the critical values. What are the endpoints? Negative 4 and 5, and our only critical value is 1. Okay? Are we good so far? That's step 3 is done. Okay? And then step 4, plug all candidates into the original function. If I plug negative 4 into f of x there, what will I get? What's that? You said it. I heard it. 16. That's correct. Negative 4 times negative 4 is 16. Negative 4 times 2 times negative 2 is positive 8. So this is going to be plus 8 minus 8. Well, plus 8 minus 8, that cancels each other out, right? So it's 16. If I plug in a 1, what do I get? I don't think it's 0. If I plug 1 into the derivative, I get 0. But I'm not plugging 1 into the derivative. I'm plugging 1 into the original function. Negative 9, that's correct. Okay, 1 squared is 1. Minus 2 is negative 1. Minus 8 is negative 9. So, okay, so we got that. Now, if I plug 5 into the original function, I get 7. And so I'm now done with step 4. And now all I have to do is pick the smallest output and pick the largest output. Of all these outputs, which one is the smallest? Negative 9. Okay, so this will be the absolute minimum. And then what is the largest output? 16, right? And therefore that makes this the maximum. Now I want to show you how I'm going to write my answers. Okay? So I'm going to say that the absolute minimum is, okay? The absolute minimum is f of 1 equals negative 9. Now let me explain why I wrote it that way. The question may ask you one of 3 things. The question may ask you, what is the absolute minimum. When they say what is the absolute minimum, they're asking you for the output value, which is -9. So the absolute minimum is -9. Or they may ask you at what x value is the absolute minimum. So now they're not asking you for -9. If you say -9, you're wrong, because the absolute -9 isn't even on the closed interval.
But they're just asking for the absolute maximum.
Well, right. And so in this case, it would be -9. But the reason I'm writing it like this is sometimes they will ask you for both. They want to know at what x value and what is the output value is the absolute minimum. By writing f of 1 equals -9, I am showing them, here's all the information, right? Okay? Now, on some optimization problems, if they're like real-life questions, if they're situational questions, they may be asking how far underwater does what's the deepest part of the river, right? And if it's in feet, then your answer better say 9 feet deep. Does that make sense? Because -9 means below water or below the water surface, right? And so you wouldn't just say the deepest part of the river is -9. Now, some people will, I promise you, some people will say the deepest part of the river is -9. And they'll be like, what does that mean? Would you say that to a person in a conversation? No. The deepest part of the river is -9. You'd be like, what are you talking about? But if you said the deepest part of the river is 9 feet deep, would that make sense to them? Yes, it would. Yeah. Yes. Okay. First of all, if you're dealing with depth and negative numbers are below water and positive numbers are above water, then you can't not get a negative number. If you got all positive numbers, that would mean that there is no depth at all. Therefore, there is no water. Therefore, there is no river. Do you see what I'm saying? We would have to have the whole question for me to really have a good conversation about it. Okay, I'm just trying to interpret for you how you might use the answer -9 in a real life situation. Okay, all right, and then I'm going to write. Any guesses on what I'm going to write for the maximum? Yep, absolute maximum is f of -4 equals 16, and we're done. We're good? Yep. Right. Let's do another one. Please. Yeah, absolutely. Yeah. Absolute maximum on that. Yeah, we're doing another one. Okay. All right. Do you guys want to try question number 2? Yeah. All right. How about this? Why don't you all do question number 2 in its entirety? I think you can probably do it in about 4 or 5 minutes. You will need a graphing calculator, okay? And then, well, do you want me to do it with you if you need a graphing calculator? All right, let's do it together. All right, let's go. Let's do it together. Right, let's do it together. Graphing calculator? Yeah. Is yours out? Is that a plug-in kind? Yeah. Are you taking the AP exam? Yes. Okay, make sure it's charged the night before. Yeah. You can also borrow one of mine as a backup if you want to bring it with you. You just can't have both of them out at the same time. Okay, question number 2 says, we've got, Rhonda, you okay? All right, we're going to do question number 2. All right, so it says g of x, equals x cubed minus 12x squared plus 35x minus 24 for the closed interval from 0 to 9. 0 to 9, right? Okay? So why don't you guys go ahead and do step 1. You don't need a calculator for step 1. And while you're doing that, I'll get a calculator ready. And I got my overhead ready there. Okay. I'm going to go ahead also in my calculator, and I'm going to plug in the original function because it's going to be necessary at the end. X to the third power minus 12x squared plus 35x minus 24. And then what I'm going to do is, in my calculator, I'm actually going to turn off that first function. Remember how you can move the cursor on top of the equal sign and then press enter, and then it will unhighlight the equal sign. So now when I press the graph button, it will not show that function. What do we get for a derivative? 3x squared minus 24x plus 35. And what am I going to do with that? I'm going to say equals 0. Now, this function has irrational roots, meaning the zeros of this function are irrational. So you can either use the quadratic formula, which I know you guys are dying to use quadratic formula, or you can use a graphing calculator. Okay? So what I'm going to do is under y2, I'm going to type in the derivative. 3x squared minus 24x plus 35. And now I'm going to hit zoom 6. Do you guys remember what zoom 6 does? It should. Zoom 6 should revert the picture back to the negative 10 to positive 10 for x and y. Then you were already there.
So it's okay that the endpoint is not showing, because I don't like that. I don't like the endpoint's not showing.
Oh, yeah, no. Well, see, I'm now actually going to show you now how to make it clearer. Okay, watch this. We only want to deal with 0 to 9, right? So what I'll do is I'll now press the window button. And do you see where it says x min? I'll put in 0. And do you see where it says x max? I'll put in 9 and then hit graph. And now I can only see the interval that I care about. Now here's the thing is we don't care about the ends. Do you know why we don't care about the ends of this graph? Because this is not the original graph. This is the derivative. What is the only thing that we care about on this? On the derivative. The what? Yeah, but not the critical values of this. The zeros of this, which are the critical values of correct. Yep. All we care about here are the zeros, which we can see, right? We don't know what the numbers are, but we can see where they are. Okay, now, here's what you may not remember. So now, for step 2 here. So we identified the derivative, and then here's what I did. Set it equal to 0. Okay, enter into calculator. Got it? Enter into calculator in y equals, right? And then press the graph button. Okay, so that you can see where the zeros are. And I recommend setting the window interval from the left to the right. Okay? Now, to identify the critical values, do you guys remember how to do this? What do you press? Second, then the trace button, and then it'll give you the calculate menu. And which option do you choose?
0?
Well, it's option 2, which spells out the word 0, right? Because we're identifying the zeros. And I'm saying it like that because some people may press the 0 button. They're not pressing the 0 button. You're choosing option 2, which is called 0. You're identifying the zeros. So second trace 2, and then you have to put in the left bound and the right bound and then press enter, right? So now, if I press second trace, option 2, do you see where that 0 is right there? It's kind of near 2, right? So what should I put as my left bound? 1. And how about my right bound? 3. And then I just press enter when it says guess, and it says we have a 0 at 1.9183. So step 2, x equals 1.9183. Is that right? Okay. And now we've got another 0, right? I hope you guys are ahead of me on this. I mean, I can slow down if you want me to. So then I'm going to hit second, trace, option 2. 1, 2, 3, 4, 5. It's somewhere around 6. Excellent. So I'm going to put 5 as my left bound and 7 as my right bound and press enter. 6.0816. That's what you guys said? X equals 6.0816. Okay, so now we have our two critical values. Now, what am I going to do in step 3? All the possibilities. X equals, I'm going to make a table of values. How many possibilities are there? There's 4 possibilities because I have 2 endpoints and I have 2 critical values. So, what are my endpoints? 0 on the left.
1.9.
Well, yeah, but I usually go all the way. I do the endpoints first and then 9 over here. Then my critical values. 1.9183. 6.0816. This is step 3. Now, let me tell you for step 4. Step 4 is the reason that I entered the original function into the calculator. Because what's that going to do, Tiffany? I'm going to be able to go back to it and get all my output values, right? So now watch what I'm going to do. I'm going to press y equals. And guess what? Guess which one I'm going to turn off? I'm going to turn off the derivative, and I'm going to turn on the original function, g of x, and then press graph again. Now, it doesn't matter whether I can see the endpoints. I can use the trace feature. I can use the trace feature in the TI-84 to find the output values. I'm going to press trace. Is anybody drowning yet? Be honest with me.
Or just trace?
Just trace, because second trace gives me the calculator menu. Somebody said yes, they're drowning. Over here. We're okay? All right, we're good. Okay, it's good, isn't it? Have you ever been in a literature class or history class or a math class? Science, probably. Science, that's where it's going to happen, right? And you're like, man, I just feel like I'm doing this, trying to stay above water. Everybody else is swimming and having fun, and I feel like this, you know? Yeah, I don't like that. I don't like for my students to feel that way. I can help you not feel that way. All right, so if I press just the trace button straight up, it's now allowing me to enter x values. So I just press 0, it says x equals 0. And now when I press enter, it says y equals negative 24. Therefore, the output value is negative 24. And it's still in trace mode. I could press the trace button again, but it's actually still in trace mode. So now I'm going to punch in 1.9183 and press enter again. Anybody get 6.0411? All right. 6.0411 times it's 11. Okay. Then I'm going to put in 6.0816. That's an x value. And the output value, I get negative 30.0411. Okay. And now I just have to put in 9, and I get an output of 48. I'm going to slow down just for a few seconds here. People catch up. Okay. So we've done steps 1, 2, 3, and 4. Now it's the easy step. Which one, Hugo, which one is the absolute maximum?
Absolute maximum is, it's G.
G.
6.0186.
Hang on a second. This is a negative value with a high magnitude. Sorry, I'm looking for the, you're giving me the absolute minimum. Okay, good. No, let's do the minimum. What is the absolute minimum?
Maximum minimum is
Wait, give me the minimum. Go back to what you were just doing. Yes. What's the absolute minimum? G of 6.0816. Okay, equals negative 30.0411. So, absolute minimum is, okay? And this, because we have negatives, the positives can't be the minimums. We have 2 negatives, so we're looking for the negative with the largest magnitude. Negative 24 is not as low as negative 30 is. Absolute minimum. Right? Minimum, yeah. I might have actually, I thought I said maximum, but I could be wrong. It doesn't help that the two of them sound so similar, have the same number of syllables, start and end with the same letters, right? Anybody else get confused by that? I teach both a macroeconomics and a microeconomics class. And every once in a while I come across materials in my macroeconomics class that says microeconomics because I didn't change the I to an A. The only difference between microeconomics and macroeconomics. Well, one has an I and one has an A. All right. Absolute maximum. Anybody in the third row? Brandon? Absolute maximum.
G of 9
G of 9
equals 48.
equals 48. There we go. Ta-da! What do you guys think? It is easy, isn't it? This is easy. Probably easier than you thought it was going to be. Right? Yeah. Now, let me be honest with you. These questions can be difficult if, okay, in the situations where you're given a real world situation. Now, we will do these, but not on this quiz coming up. On this quiz coming up, this is as far as it goes. Okay, now I may give you harder, like if you look at questions like 6, 7, and 8, or 7, 8, 9 or something, they have like, the product rule and the chain rule. You know what I mean? Okay? But other than the difficulty of the derivative, this is as hard as it gets. And you have a calculator. Now, these questions can get harder. The way that these questions get harder is if you're, given a real life situation. You have a flat piece of cardboard. You're cutting corners, or you're cutting squares out of the corners, and you're going to fold the sides up to make a box. What do the dimensions need to be of the box to maximize the volume of the box? It's a great question. It's a really good question. The thing is, you know what the hard part about that question is? Step 0. The step before this. You have to turn those words into a function, identify a closed interval, and then do step 1, 2, 3, 4, and 5. Do you see what I mean? Does anybody at least understand what we're going to probably do that. I'll probably do a video of that question. We may do one in class, but I'm not putting those on this quiz coming up. First, I want you to know how to do this. First, we learn how to swim in the shallow end. Then we'll learn how to swim in the ocean. Okay? All right. Yeah. Okay. Can I erase this one? All right. Do we have enough time for another one? Do you guys want to do a harder one? Well, we can do one off the back if you want.
Oh, yeah. Yeah, can we do one of those hard ones?
Sure. Why not? Yep. Yeah, I was accused several years ago, legitimately, that I always do the easy ones in class and leave the hard ones for you guys to do. So let's be fair here. I'm thinking 7 or 8, probably. 8's not that bad, actually. 10? I'd like to leave 10 for people who want the challenge. I would say 7, 8, or 9. Not 7. All right, let's do 7. Okay. All right, so question number 7. We have r of x is 5x squared. 5x squared times cosine of x. Okay? On the closed interval from -1 to 2. Okay? And obviously the hardest part about this problem, in my opinion, is step 1. Why don't you try to identify the derivative? This is your chance. It's your first one I'm putting you on the spot for this semester. All right, what do you guys think for the beginning of the derivative?
Right.
Hold on.
Well, okay. Well, I mean just the first term. 10x, right? We always do the derivative of the first term, right? Times what? Yeah, times cosine times the second term, right? Okay, plus Right, it will actually, I'll actually make it a minus on mine. 5x squared.
Oh, just the, oh.
If you're gonna make it minus.
Can you hand this to Gabby? Of course, Gabby's already seen this, but yeah.
Oh, no, I didn't have to do it with an honestly. Yeah, they were doing it. I didn't have a paper yet, so I was like, okay, no, I guess.
Well, now you can go get help from them if you need it, right? Yeah, they've already done it. Okay, so plus 5x squared, which is the first term, right? Times what? Negative sine x.
You can make it a minus.
Yeah, which is the derivative of this negative sine x. So we could put times negative sine x, but what I'm going to do is instead I'm going to go ahead and multiply the negative sine x times the 5x squared, and it'll turn this into a minus, right? Sine of x. So now we have our derivative, and what do I have to do with it? Equals 0. Now, what do you think I should do next?
I don't want to find the zero.
Find the zeros using a graphing calculator. Yep. I mean, I'm not saying it can't be done analytically. I'm saying that this kind of question on the AP exam is probably going to make use of a graphing calculator. So we're going to go to y equals. I'm going to clear both of these functions. Yeah.
Put both the original and the derivative.
My practice, what I personally do, is I put both the original and the derivative in, but I turn one of them off so I only view one at a time.
Okay.
And that should be a skill that you are capable of, unhighlighting one of them, okay? So I am going to put in 5x squared times cosine of x first. And also, if you take physics, your calculator right now may be in degree mode. That is a bad thing. You should put your calculator in radian mode for this class, okay? So you're going to want to be in radian mode for this. And then I'm going to turn this function off by unhighlighting the equal sign. Then I'm going to go to y2 and I'm going to put in the derivative we found, which was 10x cosine of x minus 5x squared sine of x. What else should I probably change? When I'm about to graph this, and when I graph this, it's going to show me from 0 to 9. That's right, my interval. I need to change the window because I want the window to be from -1 to 2. So I'm going to press window, and I'm going to change x min to -1 and x max to 2. Now I'm going to hit the graph button, and it's going to show me the derivative between -1 and 2. And how many zeros do we see? 2 zeros. That means there's 2 critical values. Do you want to go ahead and try and find those? We still got, this will be the last one we do. We got about 10 minutes left, but we probably won't use the whole thing. This will be the last one we do. Jim, yeah, go ahead. Rondo, can you start with it? Take a picture of that. Both sides. Yeah. Are you looking at 2 graphs? Yeah. Don't forget to unhighlight the first one. All right. So what is our first 0 here? 0, yeah. Doesn't it look like it's 0? Now, it might not be 0. You know how we can determine whether it's precisely 0? I can press trace and then enter 0, enter, and see if my output is 0, and it sure is. Yep. So my first critical value is actually 0. My first 0 is 0. What that means is that this derivative has an output of 0 when the input is 0. And then the other one, I'll just use my second trace option 2. So second trace gives me the calculate menu. Option 2 is find the 0. Where does this look like it's near? Yeah, it's a little larger than 1, right? So I'm going to go from 0 to 2. Left bound 0. Oh no, you know what? I don't want to include 0 because 0 is a 0. Let me clear that. Second calc, option 2. What'd you say? How about 0.1? That's a good idea. 0.1 on the left, and then maybe what? 2 on the right, and then press enter on guess. And I get 1.0768. Can I get an amen on that? Amen. Yes, we're good? Okay, all right. And now what's our next step? Table. Hopefully some of you are already making the table. So we've got an x equals and an r of x equals. How many columns? 4. Yep, because we've got 2 endpoints and 2 critical values. So our endpoints are -1 and 2. Got a critical value of 0. Got a critical value of 1.0768. Now, what you can do is, if you prefer, instead of tracing to get your output values, I don't know if anybody in here is a huge fan of the table feature on the TI-84. You could use the table feature. You'd have to change your table settings to ask, and then you would hit second graph, and it'll give you a table. Now here's the thing. You still have to turn off the derivative and turn on the original function in the calculator so that your output values are from the original function. So if I hit first I have to hit second window for the table settings. I have to go down to independent and change it from auto to ask. Bless you. Then I have to press second graph, which gives me the table feature. And now I can just type in my inputs. -1, 0, 1.0768, and 2. And then there's all my output values right there. But because I want to go to 4 decimal places, I actually have to hover over each one of these to get the right value. Am I going too fast? Is anybody splashing? Are we okay? All right, so at x equals -1, our output value is 2.7015.
I didn't get those.
Okay, all right. Maybe I put it in wrong. Hang on. Maybe I'm wrong. Let's go back to the original, and I got 5x squared cosine of x. Okay, are your calculators in degree mode?
Good question.
Are you plugging into the original? You're in radians?
Yeah.
All right, let me see what you got, Brandon.
Oh, sorry. We're going to be radiant, right?
You got to be in radians.
Oh, yeah. Okay.
You were in radians. Okay. Are you sure you're looking at the... This is the derivative. You need the original.
How do you know you're in radians?
Hit the mode button.
We're going to be looking at the original.
Original, yes. So now,
I got different from you still.
let me see here. Let's see here. Y equals 5x squared cosine of x. Graph. Trace -1. There it is.
Oh, I did get that one. I don't think.
Yeah, and I think that one's correct too. If I go for 0, I got, whoops, wrong one. I meant to be on the table. Second graph gives me a table. Okay, and then and then 0 is the output. When you input 0, the output is 0. Again, that means that at 0, both the derivative is 0 and the output is 0. Okay, then I've got 2.7488. And if you put 2.7489, that's okay too. And then I got -8.3229. -8.3229. So now that I have my table made up, it's easy work here. Now actually there is something, what's interesting about this? Well, that is interesting too. But now when we go to find the maximum, does anybody notice something interesting? Yeah, 2 of them are pretty close, but one of them is definitely higher than the other by 0.04. Yeah, so our maximum is at 1.0. So we got absolute. Well, let's do the minimum first. Absolute minimum is R of 2 equals -8.3229, and our absolute maximum is R of 1.0768 equals 2.7488. Is that key going around? You got it going around? You got about 3 minutes to get a picture of this key. It'll make its way back. I think you guys can get it in 3 minutes. And you can stay for an extra minute after, but we're done.